Hello and welcome to this session on compounding and discounting. This is the second session in a series of sessions on time value of money. In the introductory session to time value of money, we have seen that future value can be calculated using a formula present value multiplied by 1 plus r to the power of n, and present value can be computed as future value divided by 1 plus r to the power of n. Here, r represents the required rate of return and n represents the number of periods. The calculation of future value is known as compounding, and the computation of present value is known as discounting. The rate used for compounding is called compound interest rate, and the rate used for discounting is called discount rate. These two concepts of compounding and discounting are fundamental to most of the advanced theories in finance. Most of the valuation concepts in finance use the concept of discounting extensively. Let us now look at some practical applications of compounding and discounting. Let us take an example. If one invests rupees 50,000 in a cumulative fixed deposit scheme of a bank offering 8.5% interest per annum, what will be the maturity value of the deposit at the end of 5 years? Here what we need to understand is this is a cumulative fixed deposit scheme, which means if you invest 50,000 today for 5 years, the maturity value will be your 50,000 plus cumulative interest of all the 5 years put together. That means in between you are not going to get any cash flows. So from the details available, we know that present value is 50,000 because that is the amount you are investing today. The required rate of return R is 8.5% and the number of years N is 5 years. We have to now use the concept of compounding to compute the maturity value of this deposit. The maturity value of this deposit will be 50,000 multiplied by 1 plus 0.085 because interest rate is 8.5% to the power of 5, which is rupees 75,182.83. Let us now look at an example of discounting, or let us reverse the story now. If you wish to receive 5 lakh at the end of 6 years from now, that means you need 5 lakh for a specific purpose 6 years from now. In order to accumulate this 5 lakh, you are interested to deposit an amount today in a fixed deposit scheme offering 6.25% interest. Now the question is, how much should you invest in such a way that you will be able to receive 5 lakh at the end of 6 years, which will be the principal amount plus cumulative interest for 6 years. Here, 5 lakh is something that you want to receive in future, therefore future value is 5 lakh. The rate of return is 6.2% and the discounting, the period is 6 years. Since we are planning to calculate the present value, we are using the concept of discounting here. So if you use the formula 5 lakh divided by 1.0625 to the power of 6, we will get the answer as 3,47,533.26. That means if one invests rupees 3,47,533 in a fixed deposit offering 6.25% per annum, at the end of 6 years, the amount will grow to rupees 5 lakh. Let us now move a little more closer to reality. Many a times, the interest offered on investment schemes are not compounded annually, but at shorter intervals. In most of the fixed deposit schemes of banks, interest is compounded quarterly. That means If a bank offers 8% interest on a deposit scheme, which is compounded quarterly, what does it mean? Does it mean that the deposit holder gets 24% interest on a 1 year deposit, 8% every quarter? No, that's not the meaning. It only means that the deposit holder gets 2% interest for each quarter. Therefore, when annual compounding is done, the interest calculation happens 4 times a year. But what is the difference between annual and quarterly compounding? Let us take one example and see. I have given the picture of 1 year here, which has been divided into 4 quarters, Q1, Q2, Q3, and Q4. Let us first look at example of annual compounding. Assume that you are investing 1000 rupees today and the interest rate is 8% per annum. At the end of 1 year, under annual compounding, your amount will grow to 1080, which is present value into 1 plus r to the power of 1. Since it is power of 1, I have eliminated that. So it becomes 1000 into 1.08, which is 1080. Now let us see same deposit scheme offering 8% interest if it was quarterly compounding. In case of quarterly compounding, when you invest 1000 rupees today, at the end of first quarter, it will grow to 1020. That is 1000 into 1.02. But you are not withdrawing this amount. You have deposited for 1 year. Therefore, from Q1 to Q2, it will grow to 1040.40, which is nothing but 1020 into again 1.02. At the end of Q3, this will become 1061.21, which is 1040.4 into 1.02. And at the end of 1 year, which is also the end of Q4, the amount will become 1082.43, which is 1061.21 into 1.02. So what has happened here? In between Q1, Q2, Q3, you are not withdrawing anything. You are allowing that amount to be kept back in the bank. You are withdrawing only at the end of 1 year. Still, the amount has been cumulated and compounded 4 times in a year under quarterly compounding, whereas in annual compounding, the compounding happened only once. Quarterly compounding gives the deposit holder an additional amount of rupees 2.43 in this example. If the scheme was annually compounding, 1000 rupees invested today would have become 1080, whereas when the scheme is quarterly compounding, 1000 invested today becomes 1082.43. This is because compounding takes place 4 times in a year under quarterly compounding. So under annual compounding, compounding happens once a year at the rate of 8%. In quarterly compounding, compounding 4 times a year at the rate of 2%. So what has happened here? The number of periods of compounding has been multiplied by 4 because it is quarterly compounding. So instead of 1 period, it becomes 4 periods, and the rate of interest has been divided by 4. Therefore, what you get as 8% per annum now becomes 2% for every quarter. Using this, let us now see how compounding and discounting formulae look like in multiple compounding. Whenever you have multiple compounding, future value of your investment will be present value into 1 plus r by m raised to n into m. Therefore, present value will be equal to future value divided by 1 plus r by m to the power of n into m. Now what is m here? M indicates number of times compounding is done in a year. Therefore, m is 2 if it is semi-annual compounding, m is 4 if there is quarterly compounding, and m will be 12 if it is monthly compounding. That is exactly what we have done in our example also. So what we did in our example? In our example, 8% interest was compounded quarterly Therefore, 1000 into 1 plus 0.08 divided by 4 to the power of 1 into 4. 1 is number of years, 1 year. 4 is the value of m. The amount becomes 1082.43. This is the same amount which we saw in the earlier example. If the deposit is for 5 years, let us see what happens. If the same deposit is for 5 years, 1000 rupees will become 1000 into 1 plus 0.08 divided by 4 to the power of 5 into 4, because it is 5 years now. So an amount of 1000 invested in a fixed deposit offering 8% interest compounded quarterly for 5 years will become 1485.95. Now, it is important to note that the interest rates are always quoted in annual terms, even if the compounding is done at shorter intervals. Hence, a bank would never quote the rate as 2% per quarter. It would always quote the rate as 8% per annum, which is known as offered rate or quoted rate. Remember, even when fixed deposit schemes have quarterly compounding, they do not say it as 2% per quarter. Always the rates are quoted per annum. What the investor actually gets is known as effective rate. Therefore, if the compounding is annual, that means if it is annual compounding, offered rate, that means the rate offered by the bank and what actually the investor gets are same. But if compounding is done more than once a year, the effective rate will be greater than the offered or quoted rate. How do we get the effective rate? The effective rate is defined as 1 plus R by M to the power of M minus 1. This is the formula for effective rate. So, if we take the earlier example where it was 8% per annum compounded quarterly, your effective rate of return will be 1 plus 0.08 divided by 4 to the power of 4 minus 1, which is 0.0824. Converted into percentage, it becomes 8.24%. So what does it mean? When the bank is offering 8% interest per annum, since the deposit is a cumulative deposit where the compounding happens quarterly, the investor actually gets 8.24%. This is something which we have to always remember, because offered rate is always expressed in annual terms. Compounding may happen at more intervals, but offered rates are always on an annual basis. Nobody says 1% per month or 2% per quarter, nothing like that. It's always says 8% per annum, 8.25% per annum, 9% per annum. That is how interest rates are quoted by the investment firms. That brings us to the end of this discussion on compounding and discounting. We shall continue in the next session. We shall continue with some more concepts relating to time value of money. Thank you.